Hello AP Stat students. We're going to do a quick tutorial on adding a single random variable. So let's look at the question. Let's suppose a student averages 7 on quizzes with a standard deviation of 0.7. What's the probability that this student will score more than 24 points on the next 3 quizzes? We're going to assume a normal distribution and independent scores. So we have a normal distribution with 7 and standard deviation of 0.7. What we want to do is set up a z-score. So we want x minus mu divided by sigma. So x in this case is 24, and our mean for our distribution for the next 3 quizzes would be 7 plus 7 plus 7. We can always add. So mu will be 21. And this is a z-score, and we're looking for greater than. So our standard deviation is the tricky part. So we have a standard deviation of 0.7, but we can't add standard deviations, but we can add variances. So that would be 0.7 squared plus 0.7 squared plus 0.7 squared. And then when we're done adding those variances, we'll take the square root. So adding those variances together gives us 1.47, and then to put it back into standard deviation, we take the square root. So the square root is 1.212 approximately, so we have 1.212. And whoops, too good, so let's go to the next page. So now we'll do the math. And we get z greater than 3 over 1.212. Pull out our handy-dandy calculator. And that will give us a z-score of 2.475 approximately. So next, we're going to grab our calculator, and we're going to use the normal CDF command. And we'll plug in 2.475, and so that's our starting point. And then we want to go to basically infinity. In this case, we'll just use the number 10 because I like 10, and I'll pop that in my calculator, and that will give us a probability of 0.006, and that's less than 1%. So the probability of that student scoring 24 points or averaging 8 is very, very, very unlikely. Okay, so what we have is adding a single random variable. I hope this helps. It'll help with at least one of the multiple choice questions on the test. All right, good night. Good luck tomorrow.